Okay, so this is chapter 5, number 13. This might be the fourth time we've recorded this, so hopefully this time it'll work. All right, so in chapter 5, number 14, the situation is we're looking for a conditional probability, and we actually want to reverse the conditionality. So here it says, suppose our school is in the midst of a flu epidemic. The probability that a single randomly selected student has the flu is 0.35, and the probability that a student who has the flu also has a high fever is 0.9. So that means that the probability of them having a high fever, given that they have the flu, is 0.9. But there are other illnesses making the rounds, and the probability that a student who doesn't have the flu does have a high fever is 0.12. So that's saying that the probability that they have a high fever, given that they do not have the flu, is 0.12. Suppose a student who walks into the nurse's office has a high fever. What's the probability that she has the flu? Well, what we're asking for here is the probability that this girl has the flu, given that she has a high fever. So you can see how we've reversed the conditionality here, or we want to reverse the conditionality in order to find the probability that we're looking for. So it's worth remembering in a conditional probability that the probability of A given B is equal to the probability of A and B divided by the probability of B. So let's relate that to what we have over here. What we want is the probability that they have the flu and have a high fever divided by the probability that they have a high fever. So to do this, we're going to create a tree diagram. So the first thing that can happen if I randomly select a student is either the student has the flu or they don't have the flu. It tells me the probability that they have the flu is 0.35. So that means the probability that they don't have the flu is 1 minus 0.35, which is 0.65. Then, if they do have the flu, the probability that they have a high fever is given to me right here. Has the flu, also has a high fever, is 0.9, which means that if they have the flu, the probability that they don't have a high fever is 1 minus 0.9, or 0.1. Now if they don't have the flu, again, they could still be sick with something else, so they could still have a high fever. And it says if they don't have the flu, but they do have a high fever, the probability of that is 0.12, which means the probability that they don't have a high fever is 1 minus 0.12, or 0.88. All right, so remember what we're trying to find. We're trying to calculate the probability that they have the flu and have a high fever. That is this pathway right here, has the flu and has a high fever, and means multiply. So this probability is going to be 0.35 times 0.9, which is about 0.315. We want to divide that by the probability that they have a high fever. Well, there's two ways you can have a high fever. You can have the flu and have a high fever, or you cannot have the flu and have a high fever. Did you hear that or there? You can have the flu and have a high fever, or not have the flu and have a high fever. So what we're going to do is add the probabilities of these two pathways. So this pathway would be 0.65 times 0.12, which is about 0.0744. So now let's take this formula down here. The probability that they have the flu and have a high fever is 0.35 times 0.9, which is about 0.315. And we're going to divide that by the probability that they have a high fever, which is both of these pathways. So 0.35 times 0.9 plus 0.65 times 0.12. So that's about 0.315 divided by 0.315 plus 0.0744. Do a little bit of adding and a little bit of dividing. You get 0.809. So the probability that someone has the flu, given that they have a high fever, is 0.809, or there's about an 81% chance that I actually have the flu if I have a high fever.